Hey, good morning, folks. Welcome back to Trigonometry here. So when we left off, as far as the lecture goes, we were talking about how to graph sine and cosine. We've done a couple of those. So I'm going to go back to just a generic parent function sine and a parent function cosine. So we're going to go from 0 to 2 pi here. Halfway through is pi. Halfway to that is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. You can either estimate the halfway point, or you could have averaged them, and that worked out just fine. If I take pi plus 2 pi and divide them by 2, we're going to get 1 plus 2 is 3 pi over 2. We're going to end up with that. Now, the thing about sine and cosine is that they are bounded between -1 and +1. Okay, so sine of 0 stays at 0. Sine of pi over 2, we're going to be at 1. Sine of pi, we go back to 0. Sine of 3 pi over 2, we go to -1. And then we're back to 0 for at 2 pi. So here is my, that's a terrible function. Let's go ahead and make that better. Okay, so we're going to go ahead and draw this guy in here. There we go. And something like that. Okay, now the first thing we want to do as far as considering graphing cosecant is that cosecant of x is equal to 1 over sine of x. Okay, it's not this one. This is an inverse function. That -1 does not mean reciprocal in this case. So that's not the button for cosecant on your calculator. Okay, the cosecant button isn't really a button for cosecant. You have sine, and then you have a 1 over x button. That's how you get cosecant. Okay, but we still have to graph this. Okay, and the idea is we're going to look at these numbers here, and we're going to have to take the reciprocal of these numbers. So I'm going to start with the ones that I know how to do and say, well, the reciprocal of 1 is just 1. Okay, the reciprocal of -1 is just -1. Okay. Now, what happens here is that these numbers are close to 1. So you might take like it's 0.866. Okay. And we're going to say what's 1 over 0.866. And if you'll allow me to pause for a moment, you will. We're going to go get a calculator. Poof, there's a calculator. Okay, so really what I'm trying to do is I'm trying to get the reciprocal of 0.866. So I'm just going to type that in. So we have 0.866. Okay, we'll go ahead and take the reciprocal. Okay, just so you can see what I'm talking about. Okay, if we take the sine, let's go ahead and double check. Am I in mode? I'm in radians. So we're going to go ahead and add that. We're going to say, what is the sine of pi over 3? So we can say pi over 3. That's about 60 degrees. All right, we'll type that in. We'll say, what is that? And that's like, oh, 0.866. Hey, go figure. I wonder where I found that number for specifically. But my reciprocal of this was 1.15. So we have 1.15. So when I'm looking at my sine of 60 degrees here, I have to go above 1 here. It's going to be 1 point something. Okay. If I look at the sine of pi over 4, that's 45 degrees, remember? That was 1 over 0.7071. Actually, I want cosecant of this. Okay, so we'll go ahead and change that to yeah, I want the cosecant of pi over 4, okay? Which is equal to 1 over the sine of pi over 4. Okay? Well, we could calculate the sine of pi over 4. That's going to be the square root of 2 over 2, or 0.7071. So we can go ahead and type that in. So I have the sine of, say, pi over 4, second function pi divided by 4. Okay, and I know that this is the square root of 2 over 2, 0.7071. Okay, for those of you who are engineers, you will memorize this number, not on purpose. It just will happen. Okay, take the reciprocal of it and look at this. It's 1.4 something, so it's even bigger. So what's happening is we're going down here. It gets to be even a bigger number here. Okay, when I get to the sine of pi over 6, right, that's actually 1 over, or sorry, the cosecant. I want the cosecant of pi over 6. That's 1 over the sine of pi over 6. Well, this one I can do. I don't need a calculator for this one because the sine of pi over 6 is 1 over 2. So 1 divided by 1/2, that's equal to 2. Okay, so it gets even bigger. Okay, so we're here. You can see kind of what happens, what's going on here. Now, as we get smaller and smaller and smaller angles, we're getting numbers that are closer and closer and closer to zero. So they're getting to be very small. So sine of an angle that is small is also a very small number. Okay. And what I want to do is I want to say 1 divided by a small number. Like, what is the reciprocal of 0.01? Right? Well, 0.01 is 1 over 100. If I take the reciprocal, that's 100. If I take the sine of like a smaller angle, we get something like 0.001. It's 1 over 1,000. When I take the reciprocal, that's going to be 1,000. So as I get closer and closer and closer to zero, this cosecant value goes up, up, up. As it gets closer and closer and closer to zero, it gets bigger and bigger and bigger until it completely disappears. There's a vertical asymptote at x equals zero that the cosecant will go ahead and climb up. It never quite gets there. And remember, we can't cross vertical asymptotes. Horizontal asymptotes are guidelines and suggestions, but vertical asymptotes are hard and fast rules. We cannot cross them. Now, the same thing is going to happen over here at pi as we get closer and closer and closer to an angle of pi. Like if I take, hey, what is the sine of, say, 3 radians? We really want to deal with pi radians. That's 3.14. 3 is a little less than that. So if I say, what is the sine of pi? So if I go here and I say sine of, or sine of 3 rather, right, we're going to get a pretty small number, okay? And then when we take its reciprocal, okay, we get 7. We get a big number, right? So as we are getting, so we have this 1, and as we are going further and further and further away from it, we're getting smaller and smaller and smaller numbers, but we have to flip these as a reciprocal. We're going to get bigger and bigger and bigger numbers as we go through this. The same thing is going to happen on the negative side of things, right? The reciprocal of -1 is just -1. As we crawl closer to pi, approaching it from 3 pi over 2 into pi. So we're 3 pi over 2, and we're going back into pi. Again, this reciprocal value is getting more and more and more negative. Okay. We're going to go over here. We're going to get closer to 2 pi. It's going to get more and more and more negative. So the graph of cosecant looks like, okay? So the way that you should graph cosecant is the first thing to do is to graph sine. Go ahead and deal with that. So here's my 2 pi. Here's my pi. Here's my pi over 2. Here's my 3 pi over 2. And then we're going to go ahead and dot in what has to happen for my sine. Okay. And we're going to go ahead and just dot it in. Okay, we're not really drawing it that way. We're just shading it in so we kind of have a place to go with. And then when I turn around to watch cosecant, okay, I'm going to put in my asymptotes because I know that when sine is 0, well, cosecant is 1 over that. Well, that's oddly fine. We can't very well do that. What's going to happen here is that we're going to end up with an asymptote that comes up like this. And then we're going to keep going here and here. Now, it's important to remember that these little horseshoe things keep going. So we are at pi, 2 pi. At 3 pi, there's also going to be, um, there's also going to be another asymptote here. So this waveform is going to repeat over and over and over again, this infinite set of little horseshoes that go up and down. Now, these are not, they may look like parabolas, but they're not parabolas. Okay, they kind of have that shape. But here's the thing with parabolas, like parabolas will go further and further and further to the left and to the right. The cosecant is constrained on the left and the right. So once it gets into there, it's kind of, it's bounded, it's constrained between these two asymptotes. So it doesn't really look like I said, it looks more like a horseshoe than it looks like a parabola. So it's important to remember that these are like more like U's, right? Rather than parabolas. Okay. And that's pretty much how you graph a cosecant. Secant works exactly the same way, except that secant. So we'll talk about secant now. So we have secant x, y equals secant x. And for secant, that's 1 over cosine. So the first thing that we're going to do when we're tasked to graph a secant is we're going to go ahead and graph our cosine first. So we have 0 to 2 pi. Okay, so there we go is pi. Here's my pi over 2. Here is my 3 pi over 2. And then cosine, again, is bounded between -1 and +1. So we're going to be here, 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 and here. So I'm going to dot this in. Okay. And then realize that this goes on forever and ever and ever. Okay. There's going to be some asymptotes. Okay. When we have our cosine equaling 0, so cosine of pi over 2 is 0. So we're going to also have asymptotes here. Now, in this case, we're going to go ahead and use something like this. For the reciprocal on the negative sign, we're going to be here, here, and then we're going to come up like this. Now, sometimes students look at this and they'll say, is it really disjointed? Like, no, it's not disjointed because remember, this goes both forwards in both directions, right? This goes on and on and on in both directions. So here at -pi/2, there's also an asymptote. And even though I usually start at 0, we could have started at pi/2. That's for -pi/2. That's fine. But there's also the part of this graph that continues backwards. There's also the part of this graph that continues forwards. Okay, so it's not a disjoint graph. It's going to kind of look at it when you draw a picture of it, but it's not really disjointed. It's continuous. It's just that the usual interval that we graph over, 0 to 2 pi, cuts my secant into two different places, even though that's not really the case. But because we use 0 to 2 pi to graph cosine, sine, and cosecant, we generally leave it as 0 to 2 pi. You're going to find that that's not the same when we go to tangent and when we go to cotangent. Okay. But, it's important to remember that we pretty much stay between 0 and 2 pi. And then we have, it goes forever and ever and ever in both directions. So it's going to look like it's disjointed. So you dot in your sine or you dot in your cosine. And then after you've dotted it in, you can kind of sketch what the reciprocal is going to be because I know where to start. And I know that as this gets smaller and smaller and smaller, the reciprocal function gets bigger and bigger and bigger. And that's how that's going to look. Okay. All of the same stuff that you learned for sine and cosine work exactly the same way for secant and cosecant. So if we have a y is equal to, say, 3 cosecant of 2x minus 1, okay, plus 3, plus 4. Okay, this will do exactly the same thing. My amplitude is still the absolute value of 3, which is 3. We still have a 2 pi over b as far as my period goes. So this is going to be 2 pi over 2, which is just going to be a period of pi. We have a phase shift. Remember, what we have to do with phase shift is we have to bring that 2 out. So we have 3 cosecant of 2 times, this is x minus 1/2. We still have a phase shift of 1/2 radians, that is. Okay, and then all of the ways that we did this before with graphing sine and cosine, where I get my anchor points and I go ahead and graph them with the anchor points first, it works exactly the same way for secant and cosecant. And it's just like we have one more little thing to worry about, and that's that we usually have to graph our sine and our cosine first. And then with all of the things that we learned how to do, we have to translate that to a secant or a cosecant. Okay. But those points that we figured out first using the anchor point method is going to do the same thing for us for secant and cosecant. Okay. So I'm going to say I think that's probably a long enough video for you guys to get started with this. We will do some videos that look like y equals a cosecant of dx plus c plus d, and we'll just go ahead and practice a bunch of these until we're good at doing graphing all of these crazy functions with all this crazy stuff in it. Okay, it's not that bad. It takes a little bit of practice, but practice it, you will get there. Okay, it feels weird at first, but all you're doing is you're solving 5 linear equations, which you passed Algebra 1. You've got 5 linear equations. I have confidence in you. You can do this. And that's pretty much all we're going to do with all this. So I'm going to say thank you very much for watching, and I will see you in the next video. All right. I'm not pause. I want to stop. There you go. And quit.